Alright, so in this video we're going to be looking at histograms and how to create and use and interpret histograms. In the previous video, one of the types of graphs we looked at was a bar graph, and so this is just another type of graph. Now there's some things that we need to be familiar with as far as some different terminology and how we use histograms. So let's look at these definitions here. So first off, just understanding when we talk about a distribution, that's just referring to a function whose values are the frequencies, relative frequencies, or probabilities of mutually exclusive events. And mutually exclusive, that's a term we're going to be learning about in a future chapter, but that's just referring to events that don't overlap each other. So that's what, when we look at distribution of data, that's what we're referring to, is just we're looking at frequencies. It could be relative frequencies or probabilities. And a histogram, that's a type of bar graph that breaks the range of a numerical variable into non-overlapping intervals of equal widths. And you'll see what we mean by that in a minute. But I do want to talk about this bolded word, this word bins, B-I-N-S. So instead of having like a bar graph along the bottom, like we had the amount of protective gear worn, and we had, that was one of the bar graphs that we looked at. Or we looked at another bar graph in the previous lesson dealing with the amount of education or the type of degrees that people got. Those are all categorical variables, especially the one with the education level. Well, this is looking at along the x-axis. Instead of looking at a categorical variable, it's going to be along the x-axis a numerical variable. And we're going to break that data into bins, and they have to be equal size bins. So we'll talk more about that here in a little bit. But then there's a couple different types of histograms. There's what we call a frequency histogram and a relative frequency histogram. A frequency histogram, that displays the number of values in each interval. Okay, so the actual number of times something occurs. Where a relative frequency, that's taking the values and changing them into a ratio. Remember, we talked about a relative frequency in the previous video. So anytime you see that word relative, just remember a ratio, a fraction. So we're going to convert that fraction into a percent, and we're going to look at the percent of values, the decimal values in each interval. So here's two examples graphed below for us of what a histogram would look like. Before we get to those graphs, let's talk about how they got these graphs. So first off, it says the number of representatives that each state has in the U.S. Congress depends on the population of the state. Below, the number of representatives from each of the 50 states in the 110th Congress. That went from 2007 to 2009. All right, so we have 50 states. Some states have more and less, representatives than others. And again, it's based on the population. So you see some states only have one representative, where you can see, I think the largest number is 53. So there's a state, probably California, that's got 53 representatives. So how did they create a histogram with all of this data? Well, the first step, and we're going to be learning about this here in a little bit, but the first step is to create your bin size. So now we can look at this example. We can see that the bin size is 5. Now, I want you to think for a second. If we had a state, because we do have a few states that have 5 representatives, which bin do you think it's going to go in? Do you think it's going to go in this one, or is it going to go in this one? Because 5 is on the edge, and so we got to have a definition as far as where do these numbers go. Well, what we're going to do is we're going to define a bin size at the beginning. So let's say if we have a bin size of 5, which is what they've done here. And if we're going to start at 0 like they did, 0 to 4 is a bin of size 5. Now you might be thinking, no, that's only 4 numbers. Well, you got to remember you're counting 0. So if you count 0, 1, 2, 3, 4, that is 5 numbers. And so then the next bin would be from 5 to 9, not 5 to 10, 5 to 9, because 5 to 9 is also 5 numbers. If you count on your fingers, 5, 6, 7, 8, 9, that's 5 numbers there. So the next bin would be 10 to 14, and so on. So then what they did is they counted up all the numbers in each of those bins. So looking at 0 to 4, there's no states that have 0 representatives, but if we counted up all the ones that are between 1 and 4, you could just start counting, going like this. Okay, so we have 1, 2, 3, 4, 5, and so on. And then you'd put your total, how many you'd have in each bin, and then you could put those into a graph. Now the way that they got the relative frequency is then they would take each of those numbers. Remember, there's a total of 50 states. So if there were 20 states that had between 0 and 4 representatives, 20 divided by 50 is 0.4. So that's how they came up with the values for the relative frequency in that second graph. All right, so here's what I want you guys to do. So in these questions, A through E, I want you to answer A, B, D, and E on your own. I think you should be able to answer those without any help. But I do not want you to do letter C. I want you to wait on letter C. So I want you guys go ahead and pause the video and answer A, B, D, and E. And then we're going to work together and talk about how to find where the median representative, where the median value would end up being. All right, so go ahead and pause the video and hit play when you're ready to check to see if you got those correct. All right, let's see how you did on those. So letter A, it says about how many states have between 15 and 19 representatives. So again, you just look at the graph and you would see that that's approximately 4 representatives. Now in part B, when it says what percent of states have 20 or more representatives, that's where you'd want to use the relative frequency, and then you can interpret those that answer as a percent, which I forgot to write down, so that's actually 8%. But it's, so you'd add together the 0.04, again you just estimate those, 0.02 and 0.02, and you get about 0.08 or 8%. Again, we're skipping letter C. Then letter D, how many states have 5 to 14 representatives? Well, that again, you look at that first bar graph and you just write down approximately how many, from reading the graph, how many would have between 5 and 9 and 10 and 14, and you get 17 and 5, and you add those together and you get 22. And then letter E, it says what percent? So again, we're going to be dealing with the second graph of states have fewer than 15 representatives. So again, if you use the relative frequencies and add those together, we get 0.84, which as a percent would be 84%. Now let's talk about letter C. It says, in what bin does the median number of representatives fall among the 50 states? Now it's not asking for the median, it's asking it for in what bin would we find it in. Well, remember we had let's just review what a median is. Remember, a median is where we find the middle number when they're in order from smallest to largest. Now don't worry, we are not going to take and put these values in order from smallest to largest because, like I said, it's not asking for what is the median. It's asking for where would that median fall. So remember from the previous video when we talked about medians and we talked about, well, if you have a large set of data, if you want to find the median, remember we had a little trick to do that. And that trick would be to just find the middle by dividing by 2 and then tacking on a 0.5 at the end. So 50 divided by 2 is 25. So that does not mean the median is a 25th term. It means the median would be, if you add 0.5 to that, would be at the 25.5 term. So between the 25th and 26th term is where you'd find the median number of representatives. So what does that mean for this problem? Well, we know that in this first bin, we have our first 20 numbers. In our second bin, we have our next, if we estimate that to be 17 numbers. So that means the 25th number is not going to be in that first column, it's going to be somewhere in this column. So we don't need to know what the actual value is, we just need to know that it's in this bin. Now the way we would describe this bin is we would say it's in the bin from 5 to 9 states. Now there's a bunch of different ways that we could write this. We could write this in words saying 5 to 9. Now the way that you could write this using an inequality, there's a couple ways. We could say 5 is less than or equal to the number of representatives. So we could use R for that. So it would be between the 5th and 9th, or between 5 and 9 representatives. Or we could write it like this. Because the second way is not saying that 10 is included, it's less than 10. So either one of those, any of those would work. Personally, I like using words just to make it a little easier. You don't have to worry about inequalities, but that's how you'd write it using inequalities. So just to review, if you ever need to find the median for a large set of numbers, just take the number of items that we have, like in this case we had 50, divide by 2, and you get 25, and then you just always add a half. So if we had, let's say 35 numbers, and we divide by 2, well, we would get 17 and a half. Well, if we add a half, that means the middle term would be the 18th term. So that's just, remember, a real quick way to be able to find the median for a large set of numbers. All right, now what if you have to draw your own histogram? Let's talk about that. So again, we've talked a little bit about this already. But your first step is to organize the data into equal size bins. You want to first, basically then, unless they tell you, you can choose a bin size of your choice. And then after that, you're going to tally the number of items in each bin. And then you're just going to draw the histogram. And we're going to include labels and a title. So you want to make sure that you're descriptive, remember, with that. So let's talk about this example. So here we have the daily high temperatures in March, 1 year in Lincoln, Nebraska. Create a histogram using that data. All right, so the first thing I'm going to do is we need to figure out what should our bin size be. Well, when I have a whole bunch of numbers like this, it can be a little overwhelming at first. And so what I like to do is try to find, well, where is my smallest value in this set? So I see that my smallest value looks like 27, and my biggest number in the set looks like 71. I don't think I see any numbers bigger than 71. So I want to make sure that my bins are going to include all those numbers. So I don't have to start at 0. Now, you also don't want to necessarily start at 27 because that can be really confusing when you're trying to break up your sets into bins. So what I'm going to do is I would suggest counting by 5s again. And we're going to start with then 25. Okay, so our first bin would go from 25, but not 25 to 30, it'd be 25 to 29 because that is a bin of size 5. Again, if you don't believe me, count on your fingers. 25, 26, 27, 28, 29. Yeah, 5 numbers. So the next bin would be 30, 34, then 35 to 39, and so on. You want to make sure you keep going until you get to the end, which the last bin would be from 70 to 74. And then what you're going to do is you're going to go through and you're going to count up. Now there's a couple different ways we could do that. We could use tally marks. So if every time we have a number, we could just do a tally. So you could just start over here and say, okay, 69, that's going to be in the bin that has 69, and put a tally mark there, and then put another bin in the bin that would have 60, and just keep going down the list that way. Personally, I find that's the best way so you don't miss any numbers. Otherwise, what some people do is they'll just count up all the ones and cross them out too as they go along. I would highly recommend crossing them out as you go along. So if you wanted to count all the 25 to 29 numbers, well, I see that 27. I don't see any of the other ones, so I would just say there's just one there. And do it that way. So it's just your choice, but those are a couple different methods you could use. So what you're going to do is you're going to do that, and then you're going to go over here. You're going to create a histogram. Now, since we're not starting at 0, since we're going to start at 25, now when we're labeling this down at the bottom, we would not do 29. Remember, we would have 30 here, because that represents the start of the next bin. But this first bin doesn't go from 0 to 25, so we're putting a break. So we're going to put almost like looks like a heartbeat. But that's a break in the graph. And that just identifies the fact that we're skipping to 25, but then after that, we're going to consistently use the same scale. So we'd have 25, 30, 35, and so on. So why don't you guys go ahead and pause the video and set this up. So fill in the numbers, so set up the rest of these bins here. Put the numbers into the bins and then create your histogram, and we'll check that. Don't forget, when you create your histogram, to include labels for your x-axis, your y-axis, and give your graph a descriptive title. So pause the video and do all of that. All right. How did your graph turn out? So your graph should look very similar to what I have. If not, make sure that your tallies are all correct. You can always double check and add up all the numbers too and make sure that they tally up to be the correct number that you had in the original set of data. And then make sure too that you label your axes and include a descriptive title. So here we can see that if I just had the graph and I didn't have any other data, we would be able to get everything that we need. We know that this is looking at the daily temperatures and not just throughout the year, just in the particular month of March and a specific location in Lincoln, Nebraska. And that we know that these temperatures along the x-axis are in degrees Fahrenheit, and the left axis, those numbers are referring to how frequently those different numbers or temperatures occurred. Now there's different ways that we could analyze and describe a histogram. One is that, so the first one is using this word skewed. Distribution is skewed to the right if it's bunched up on the left side with what we call a tail stretching towards the right. Okay, so think of it this way, like if you had a graph, let's look at one where we have where it's skewed, like especially this middle one here. So this one we would say it's skewed right, because if you were to ski down this hill, you would be skiing and you'd be going down the right side of the hill. So we would say that it's skewed right. Or the other one, the first one there, you can see that that one, it's not perfectly skewed, but there is a definite push where all the data is on the right side, and it kind of gets a little bit gradually less on the left side. So we could say that it's lightly skewed left. Now that middle one, you could see that that one's called, we call that symmetrical. It doesn't have to be perfectly symmetrical to be called symmetrical. But let's look at that definition here. That's a third bullet point down. A distribution is symmetrical when the two sides are approximately the same shape. The key there is that it's approximately, it doesn't have to be perfectly the same shape. And again, so when we're describing a graph, we can describe it as, we can look to see if it's skewed any one direction. Again, if it's skewed right, the one time that people make a mistake is they think that it's skewed in the direction that we have the most amount. So the people would get confused and say that this middle graph is skewed left. That is not the way you need to look at it. Look at the direction the tail is going. So this is skewed right. And if it has a tail, describe it and look to see if it's symmetric. So that is how we describe a histogram. Now we're actually going to end there, so in your notes you don't have to worry about doing the other examples if you have it. So that is it. So hopefully that makes it easier for you to understand how to work with and create your own histograms. And like I've said before, make sure you come to class tomorrow with any questions you have from these notes.